Hi, welcome to section 5.1, area units. Okay, so our objectives are to define area and perimeter and use the area model. Alright, so in class, for those of you that were there, we started out with the problem for table for 22. So just to refresh what we did, the problem was you are preparing a meal for 22 people. You want all the people to sit at one rectangular table. Draw all the possibilities that you could have for your table size. What would be the size of the table where you could fit the most amount of food? What would be the size of the table where you'd fit the least amount of food? And we found that we would have a table that's a 5 by 6, a 4 by 7, a 3 by 8, a 2 by 9, and a 1 by 10. And we found the areas of each table and found that the 1 by 10 would have the smallest area, but all the perimeters would still be the same. Okay, so here is a couple different problems. So first of all, we're going to define area, and area is simply the amount of space a region covers, and it's measured in square units, and the perimeter is the distance around a figure. Okay, so here's a couple different problems that we want to do. Let's say that I have a problem, a figure that looks like this. And we'll call this figure A. So I want the area of A. So the area is simply, if I count all the little squares inside, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the area of A is 14 square units. Okay, now the perimeter of A would be the distance around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So it's just 20 units. So that's the difference between area and perimeter. I have one more example that I want to show you that I want you to figure out the area of. So let's say I have this figure right here. It's just a simple square, but around it is a rectangle. And what I want to do is find the area of the shaded. So let's shade this area. So what will be that area? So area of the shaded. So we just simply do the same thing. We count the boxes that are shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 square units. So the area are the units inside, perimeter is the distance around. Okay, so now we use the area model differently in mathematics and at different levels. So we can use the area model to demonstrate the distributive property. We can use an area model to demonstrate multiplying binomials together in algebra, and we can also use the area model to multiply fractions. So let's do example 1. Use the area model to show the distributive property. So remember, the distributive property means that if I take an outside number, I multiply by the stuff inside, and it's an addition problem inside. So I could say, well, 3 times 17 is equal to 3 times 10 plus 7. And so here is how I could show that. So in example 1, there's my 3, and now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 3 because that's 3 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 10 plus 7. So if you look, 3 times 10, this inside is 30. 3 times 7 is 21 units. So if I add those two together, I get 51. So in other words, it's 30 plus 21 equals 51. Okay, so that's how we can use the area model to show the distributive properties so that kids can see that I'm just taking 3 times 10 and I'm also taking 3 times 7. Alright, so let's look at example 2, the area model using in algebra for a binomial times a binomial. Most of you learned how to do this using FOIL. But let me show you what's really going on. So you don't need to use FOIL. So let's say that I have x plus 2. X plus 2 is right there. And so I'm going to just go like this. And over here we have what, 2x plus 3. So here's 2x plus 3. Alright, so what I'm saying here is, in this box, we are going to take x times 2x, which is 2x squared. Then in this box, it's x times 3, which is 3x. And then in the bottom, we have 2 times 2x, that's 4x. In the last one, we have 2 times 3, which is 6. So if you can see now, what I have is 2x squared plus 3x plus 4x plus 6, which we can add like terms, 3x and the 4x, so we have 2x squared plus 7x plus 6. So that's an area model. You're just multiplying each pieces, all the pieces together. Okay. All right, and now the last one is multiplying fractions. So to use the area model to represent fractions, let's say I have 2/3, and I want to take times 4/5. So 2/3, I have a 3 or 2 out of 3 pieces here, and I'm going to have 4/5 over here. So I want 5 pieces. 1, 2, 3, 4, 5. Okay, basically what I do is I only care about 2/3 of the ones going across, and I care about 4/5 of the ones going down. Right? And so this is the part that I care about. And if you count the pieces inside, There's 1, 2, 3, 4, 5, 6, 7, 8 that are shaded out of a total of 9, 10, 11, 12, 13, 14, 15 pieces. 8/15ths. Area model for multiplying fractions. Alright, that finishes section 5.1. Thank you.